Hey guys, welcome back to another Algebra 2 lesson. We're going to begin with solving linear and quadratic systems. Now you may recall we solved systems of linear equations using substitution and elimination and graphing. And we're going to take that and now we're going to build upon that and throw in some quadratic systems. So we're going to look at linear and quadratic equations and make that a system to solve. Okay, so let's just recall first how to solve the system by using substitution. Remember, substitution is where we take what y is the same as, and we take out this y, and in its place, we put that whole thing that it was the same as in there. That's substituting it in. So we got 3x plus 2, and in place of y, I've got 2x minus 1 equals 12. Now recall, the reason that we do that is because now this whole thing is written in terms of x. So we're going to go ahead and distribute 4x, take away 2. I'm going to add 2 to both sides, combine my like terms. So I end up with x equals 2. Now that I know that x equals 2, I can plug it back in here. 2 times 2 take away 1 is 3. So my ordered pair solution is 2, comma 3. And you could go ahead and try this on your own. The solution for this one is 4, negative 2. Okay, and now we're going to look at this one, solving using elimination. So how do I solve using elimination? Well, the thing is we've got to get one of the variables to eliminate. Let's see if I can get this to erase a little quicker here. Nope. Okay, so anyway, we want to eliminate one of the variables. So when I'm looking at this, I see really quickly, if I could get this to be a positive 4, that's a negative 4, then it's going to eliminate. So to change 2 to 4, I'm going to have to multiply everything by 2. So I end up with 10x plus 4y equals negative 26. And then I still have my 9x minus 4y equals negative 31. Now I'm just adding these two equations together. 10x plus 9x is 19x. 4y plus a negative 4y, those eliminate. And negative 26 plus a negative 31 is negative 57. Divide both sides by 19, and x equals negative 3. Plug that in. 5 times negative 3 is negative 15. Add negative 15, that gives me 2. Divide by 2, that gives me 1. So my ordered pair solution is 3, comma 1. Again, I'm not going to take the time to work out number 4, but the solution is negative 1, 3 if you work it out on your own. Okay, so taking this now and applying it to today's lesson, we have a system that we want to solve using substitution. However, this time I can see that I do not have two linear systems. I've got a quadratic system because of this x squared, but we can still work it out the same way using substitution. So I know that y is equal to negative 9x plus 4. So I'm going to come up here and take out this y, and in its place, I'm going to put the negative 9x plus 4, and then keep my equals 20. So notice, my equation is entirely the same, except for my y is replaced with this value of y, negative 9x plus 4. So we can combine our like terms, and I ended up with x squared minus 6x. I'm going to subtract 20 from both sides. So 4 take away 20 is negative 16 equals 0. This is nice. I can see that I can factor this. I'm looking for factors of negative 16 that add to give me negative 6, and that's going to be negative 8 and 2. So I'm going to rewrite this as x minus 8 times x plus 2. It equals 0. So now what we can do is solve. X minus 8 equals 0, and x plus 2 equals 0. So x would have to be 8, right? Add 8 to both sides, subtract 2 from both sides, x equals negative 2. So we're almost done. That's the thing about these problems. They take forever. So I have this x equals 8. I need to solve for y. So when x is 8, I end up with negative 9 times 8 plus 4. So that's negative 72. Plus 4, which is negative 68. So when I plugged in an 8, I got out negative 68. Let's plug in my negative 2. Negative 9 times negative 2 is a positive 18. 18 plus 4 is 22. So when I plug in negative 2, I get out a 22. So this is my other ordered pair solution. So we have just figured out that the solutions to this system of it's a linear equation and I don't know why I jumped screens here. It's a linear equation and a quadratic equation, but the solutions are 8, negative 68, and negative 2, comma 22. So think about what that means. If I was to graph these, then they would intersect at these points. I'm going to have a parabola that is intersected by a straight line at points 8, negative 68, and negative 2, 22. And you can see over here that is the answers, or maybe you can see it. I'm not sure if you can or can't, that we came up with. Okay, so back over here, example 2. We're going to solve the system of equations using elimination. So this time, instead of using substitution, I want to use elimination. So what I'm going to do is I'm going to move this y over so that they're set up kind of similar. So I have x squared, I'm going to leave a little space, minus y equals 5. And underneath of that, I'm going to put minus x plus y equals 7. Notice the way that I lined this up so that when I add them together, I don't confuse myself and try to add unlike terms. X squared plus nothing is x squared. Nothing plus a negative x is negative x. Negative y plus y is 0. Those eliminate. And 5 plus 7 is 7 and 5 make, what is that, 12? Okay, so I'm again going to subtract 12 from both sides so that I can factor it. X squared minus x minus 12 equals 0. So to write it in factored form, I'm going to have x minus 4 times x minus, or positive 3 equals 0. So I know that x equals a positive 4 and x equals a negative 3. So plugging those each back in, we can plug them into whichever one we want. It doesn't really matter. 4 squared is 16, so 16 equals y plus 5. So subtract 5 from both sides, and y must equal 11. So when I plugged in a 4, I got out 11. Now let's plug in negative 3. Negative 3 squared is 9. Y plus 5, so subtract 5 from both sides, and y equals 4. When I plugged in negative 3, I got out a 4. So my ordered pair solution is negative 3, comma 4. All right. Let's see. Now you try this one. Okay, so I worked it out. I set it up so that my terms lined up, and then I had to times this second one, everything by negative 1. So I got a positive 3x minus y equals negative 2, combined my like terms. And once I worked it all out, you can see where I did that over here. I got negative 6, negative 16, and 3, 11, which is the correct solutions. All right, so now what we're going to do is we're going to try to use a system of equations to solve. So right now we have this big long thing all equal to each other. So what we can do is we can rewrite this as x squared minus 2x plus 6 equals y, and 4x plus 1 equals y. Now, at this point, what I would do if I was working this problem out and I was doing virtual learning at home, rather than sit here and spend hours trying to solve this, I would go to Desmos, graphing calculator here, and I would type in, let's see here, what was it? X squared minus 2x plus 6, y equals x squared. Okay, sorry, had a phone call, but I got that typed in while I was on the phone. So here are our solutions. We can see where the two lines intersect. And if you want, you could sit there and go through and solve this out and graph it, but we come up with the solutions of 521 and 1, 5. And I encourage you, try it. Let's see if you can do it. 1, 5, was that what I said? And 521. Sorry, the bell rang so you can hear everybody out there. All right, and so then the last one, you're going to try it again. You're going to set the two equal to each other. You can solve by graphing using Desmos. You can solve using a system of linear equations and using substitution or elimination. It doesn't matter to me how you do it as long as you are able to get the correct answer. And of course, I think using Desmos is the easiest. So you try it, let me know what you get, and that is all I have for today.